Good morning. In our last lecture, we started the chapter number 3 from paper first, that is transducer. And in that transducer, we completed the types of transducer: sensor, thermistor, capacitor transducer. Now, today we are going to see the linear variable differential transformer. Okay, so this is a transformer, but it is a differential transformer. What is mean by differential? Let us see here. So this is the principle of transformer. So it has a single primary and single secondary. If we apply AC current to this primary, then varying magnetic field is generated at the primary and this is cut by the secondary. Okay, if this field is cut by the secondary, then EMF is induced in the secondary coil. So this is nothing but a transforming action. Okay, so this is transforming action, and these two lines, what it means, the two lines in the symbol of transformer indicate this is iron core. Okay, this is iron core. Why we are using this iron core? So core means what? These two windings are wound on the same former. That means there is a solid iron, and over that we are wound these two coils. But there are some different methods to create a core, but here we just simply consider this is the iron rod of iron. Okay, and then these two windings are wound on the same iron core. Okay, so this iron core is used to concentrate this surrounding magnetic field in the iron core, so that the EMF is increased and the mutual inductance is increased. Okay, so self inductance and mutual inductance. So there are two types. We know that self inductance means there is single coil and EMF is induced in the same coil, that is the self inductance. And mutual inductance means there is one coil which generates the magnetic field, it is cut by the secondary coil and EMF is induced in that, it is called as mutual inductance. Okay, sorry. So there is another principle we have to know that. Okay, suppose this is a coil. Okay, so and if we apply the varying current AC voltage is applied, then when current flows through this coil, EMF is induced in its coil, is called as back EMF. Okay, it is called as back EMF. So this back EMF is depends on the AC frequency applied, number of turns, and the core of this coil. Okay, this EMF, back EMF is depends on the AC frequency applied, the number of turns, the and the cross sectional area of this, or we can say that there is a core. Okay, so it depends on the core also. Okay, just let's see, you have to know that this EMF is depends on three factors. Okay, briefly, the one is AC frequency applied, number of turns, and the core, which type of core is used for this coil. Okay, so if there is no core, then it has some inductance I. If we insert an iron core in this coil, then it has another inductance, say I dash. Okay, so this is inductance I when there is no core, and this is inductance I dash when there is an iron core. Okay, if we compare these cores, then we find that this I dash is greater than this I. What we are changed? Only we change the core. Okay, this is the same coil. Okay, there is a no core, that is air core. We simply consider that it is the air core, and this coil is having inductance value I, and if we insert this iron rod in this coil, then it forms in the iron core. Okay, then it has an inductance value I dash, and if we compare these two, I dash becomes greater than I. Okay, what is the conclusion? Conclusion is that if iron core inductor is having greater inductance value than the air core. Okay, simple conclusion is iron core inductor is having greater inductance value than the air core. Okay, so we know that there is only difference of core, because same wire is same, number of turns is same, this cross sectional area is same, length is same, and just we put an iron rod, that is core, inside the coil, so that inductance value of that iron core becomes greater than the inductance value of the air core. So this is the basic thing you have to know. Okay, so this is a basic thing. So iron core coil is having greater inductance than the air core if number of turns are same wire is used. Okay, so you have to keep in mind this. So now we see the L.V.D.T. Now we turn to the L.V.D.T. linear variable differential transformer. Okay, so in this L.V.D.T. there is a single primary coil and two secondary coils. There is a single primary coil and two secondary coils, but these two coils are connected in out of phase. Out of phase means, so if we connect these two coils and if we observe the voltage, then we get the difference between these two voltages. So Vs1 is the voltage generated by secondary one, Vs2 is voltage generated by the secondary 2, and if we connect like this, we get the voltage, that is a difference voltage between these two. So that's why the name is given differential transformer. Okay, why name is given differential? Because there are two coils and connected in out of phase, so that we get the voltage that is equal to difference between the two secondary voltages. Okay, so this is the logic diagram of this L.V.D.T. Okay, or we can say that this is a symbol of L.V.D.T. But actually L.V.D.T. is these three coils are wound over a single core, and there is iron core. So this is, we can move that iron core in and out. Okay, so there is iron core, we can move that iron core in and out, and these three coils primary and these two secondary coils are wound on the same former. So there we say that there is the insulating tube, plastic, it may be a plastic tube or it may be a ceramic tube. So these three coils are wound on an insulating tube. Okay, and there is an iron core inserted in that tube, so that we can move this iron core in that tube. Okay, so see here there is a primary, and let us see, consider there are two secondary windings. Okay, and these are connected in out of phase, so that we get the difference. Okay, so this is a L.V.D.T. linear voltage differential transformer. How it works? Working is very simple. Okay, so initially this rod is inserted fully in this insulating tube over which these three coils are wound. Okay, so initially when this rod is fully inserted, then this secondary coil is also having also having the iron core. This coil is also having an iron core inside it. So these two windings which are having same number of turns, okay, the whatever the voltage developed at both the windings are equal, V1 equal to V2. So if we connect this out of phase, we get Vs1 minus Vs2, that is 0 volt. So this is the, consider this is the first situation. When rod is fully inserted in the tube, both the windings are having iron core, and whatever the voltage developed, these both are equal, and we get the difference because we are connected in out of phase, so we get a 0 volt. Whatever the AC voltage is applied to the primary, then the voltage developed in the secondaries, these are equal and opposite, we get the 0 volt. Okay, so this is another symbol. So this is the coil primary and these are the two secondary coil, there is the iron rod. Okay, initially this rod is at the center. Now we are going to shift this rod to the left or to the right. Okay, consider we are going to shift this rod in the left. Okay, if we move this rod, consider this one now. Okay, this is the primary coil and these two are the secondary coils. So just the symbolic representation. Okay, and these are connected in a out of phase. Now this rod is moved like this. Okay, sorry, this rod is moved like this, in this way. Okay, so what it indicates here, so this secondary coil, okay, so S2 secondary, S1 is secondary, and this is the primary. So this is the primary, secondary coil, so this is also secondary coil. So whatever the voltage developed as Vs2 and here voltage developed is Vs1. So if we consider this one, if we rod move from the left side, so this coil is half iron core and half air core. Okay, and this coil is full iron core. This coil is full iron core. That means whatever the voltage developed here Vs1 and here Vs2, if we compare these two voltages, we get Vs1 is greater than Vs2. Why this happened? Because this is half iron core and half air core. So here is full iron core. Here is full iron core. So that's why Vs1 is greater than the value of Vs2, and we get some voltage here which is in phase of Vs1. Okay, we get something difference, Vs1 minus Vs2. Okay, we get some voltage which is in phase with Vs1, but here when the rod is at the center, we get Vs, difference in voltage, equal to 0 volt. Difference in voltage Vs equal to 0 volt. Okay, again if we move the rod like this, then consider this condition. So this is the primary and two secondaries. Okay, then these are the two secondaries, and suppose this iron rod is at this condition. Okay, that means this secondary is fully air core, this secondary is fully iron core. Okay, so in this case this Vs1 is greater than this Vs2, and we get a more difference in voltage in phase with Vs1. So we get the more difference voltage, and which is in phase with Vs1. Similarly, if we move this rod on this side, if we move this rod in this side, the Vs2 voltage becomes greater than Vs1, okay, and we get the difference voltage which is in phase to Vs2 if you move this rod on this side. Okay, so again if you move on this side, this voltage goes on increasing, and if we again move on this side from the right side, this voltage goes decreasing, okay, and this becomes increasing if you shift this rod on this right side. Okay, so what is the purpose of this? Just only if we shift this rod from left or right, we get the difference in voltage. So what is the use of purpose of this? A linear variable differential transformer. Okay, so just we move this rod and we get the difference. If we move this rod on this side, we get the voltage which is in phase with secondary one. If we move this rod on the right side, we get the difference voltage which is in phase with the secondary 2. Okay, if we move on this side, this voltage goes on increasing. If we move on this side, this voltage goes on increasing. Okay, if we move on this side, this voltage in phase with this one. If we move this left side, this voltage, difference voltage is in phase with the this one. Okay, so what is the purpose of this? So purpose of this is a sensor. Okay, so this is one type of sensor which converts displacement. Okay, so we convert displacement, displacement of this rod. That means it convert displacement into the voltage. So this is a sensor. Displacement of this rod is converted into the voltage. That means what is which type of this sensor? This sensor senses the displacement. Okay, it is a sensor. It is just like a transducer. Transducer converts one type of energy into another type. But this transducer is a sensor which is used to convert this displacement into the voltage. Displacement is converted into the voltage. Obviously this requires a primary voltage. Okay, so keep in mind that you have to apply some AC voltage to the primary, then and then only you get this difference. Otherwise, if there is no voltage, we don't get the difference. Okay, so you have to apply the voltage, don't forget this. So you have to apply the voltage to the primary of this L.V.D.T, then and then only you will get the difference. That means this sensor is of having an passive transducer. Passive transducer and active transducer. There are two types of transducer, we know that. Okay, you have to study, then you will know very well. Okay, there are two types of transducer, active transducer and the passive transducer. It is a passive transducer, means we have to apply some external AC voltage or external voltage source so that it convert displacement into the, if there is no voltage, if you move this rod, we don't get the voltage. Okay, so for this voltage you have to apply this primary voltage. So that means it is a passive type transducer. Okay, active transducer is directly convert this movement or this physical quantity into the electrical voltage or current. But here it is required to apply some voltage. So it is a which type of transducer? It is a passive transducer. Okay, which convert a displacement into the voltage, and you have to apply the AC voltage. What happens if you apply DC voltage here? If we apply a DC voltage, then there is no voltage generated at the output. Why? Because the transformer only works on AC voltage. Transformers only work on AC voltage. Mutual inductance or self inductance is also nothing but it works on the AC voltage. Transformer doesn't work on DC voltage, so that's why we have to apply here AC voltage. And there is a passive transducer. Okay, passive means we have to apply AC voltage, and displacement is converted into the difference in a voltage. Okay, so this is the physical quantity is converted into the electrical quantity, so it is a sensor. Okay, so this type of sensor L.V.D.T is very sensitive to the displacement. If there is a small change in a position occurs, we get a difference or change in a voltage. That means first advantage of this L.V.D.T is it is a very sensitive. Okay, it is a very sensitive. If there is a small change in the rod, we get a voltage. Okay, it is a very sensitive. Okay, and this is a transformer. We know that this operating temperature range of this L.V.D.T is very high. Second advantage is maximum operating temperature range. Operating temperature range is high. Okay, so this is another advantage, but there is a very we can say that there is this one disadvantage of this L.V.D.T is it is a transformer. We know that it has a big in size. Okay, so there is the primary, then core, then we have to insert this iron rod. That means this is a big in size, but it is a very expensive. Cost is more and big in size, so this is a disadvantage. Okay, cost is more and big in size, so this is a disadvantage of this sensor. And another advantage is it is very sensitive. Very small change you get the voltage change. It has operating high temperature range. Okay, so this is a L.V.D.T linear variable differential transformer. Okay.